Hi, and welcome to day 2 of our biomolecule unit. We are going to start by reviewing the answers for what we considered to be matter versus not matter. So on our page, 18 of our notebooks, we went ahead and added some details. Up at the top, we added some, let me see if I can make this a bit bigger. We added some information. We started with Einstein's famous equation E equals mc squared, which just simply, and I don't mean to be, it's not simple. It's actually a pretty complicated equation. However, it shows us that energy and matter or mass are deeply connected. So E equals mc squared has a direct relationship to what we were trying to do. And so many of you really struggled with whether or not you're going to put these terms or ideas or words into the matter side or the not matter side. And that made perfect sense because really they are deeply connected to each other. So what we did do is we added a little bit of information. We said that matter is something that has mass and volume and that it very often, well, not very often, it will always cycle. You cannot create or destroy matter, that it just is going to change its partners. So it's going to switch combinations. Energy, on the other hand, which is what we found down here, we found that most of our not matter was either energy forms or they were ideas or feelings. So we kind of focused on the energy piece. And so energy is the ability to do work. And when we were looking for a little bit more information, we found that energy can't be created or destroyed, just like matter. It just is converted to a different form. So when we consider that in biology class, in biological or living things, energy, every time it's transferred from one thing to the next thing to the next thing, energy is becoming less usable. So this series of arrows are trying to indicate that we can start with this amount of energy and all of that can be accounted for. It's this arrow's worth of energy and this. So some of these pieces are converting to a less usable form. So living things will be able to have access to less and less energy as the transfers occur. So that's all this image is trying to show. Matter cycles, one atom joining up with a different atom, and then a different atom, and then a different atom. And then energy becomes converted from one form to the next form to the next form. And as far as biological things are concerned, the energy becomes less usable. We also took a look at an answer set, and these answers were very simply me going through what previous students had taken a look at and shown. Let's see if we can get this up, and no, we can't. Shown and documented what is matter versus what's not. So we went through and we took a look at all of the cards. So let me have that loaded and you can take a peek. So clouds and bacteria, smoke and paper, skin and gasoline are all matter. Not matter, heat, sound, gravity, force, fear, fire, electricity, and temperature. They also gave you a little example. And then we tried one more: water, dissolved sugar, air, sun, soil, ketchup, ocean, dust, batteries also belongs over here. And then other things that were not considered matter were light, love, thoughts, energy, pressure, magnetism, sadness, and moonlight. And then they went with one more example. This set of information was reviewed by students, and if a student had a question where one of their terms belonged, we went through and troubleshot that, made certain that they had what they needed. So we'll get rid of this also. And so the next piece that we did was we went into our notebooks and we started looking at our molecular model kit. So I'll show you that. And we built a bit of an information page. So back over here in our notebook, make this nice and small. On page 19, we got out these kits, and they had a whole bunch of different colored particles and twist ties and then little tubes to make them connect. So we had to make certain that we were actually documenting this. So this was going to be our 4-pronged carbon. So there's one, you can see it a little bit better if I hold it at an angle, 1, 2, 3, 4 bonding options that carbon's got. That's the black one here. And so we wrote a little bit of information here, and then we could do a short form. Then we looked at oxygen. Nope, we looked at hydrogen next. Hydrogen was our little white spheres. Even though that they have little holes in them, we're not going to be using them. We're only going to be using the sticks. And so we wrote down our information about hydrogen on our periodic table element. This is one atom of hydrogen. And then we looked at our oxygen. Our oxygen was our little blue spheres, and they've got two options for bonding. Again, we've got our little periodic table box, our atom of oxygen, and then oxygen has got 6 electrons in its outside shell, and we need 2 more. And so to get those 2 more, we're going to have these 2 bonding arms. It's not going to reach out with 6 electrons. That's going to be too much. So we have all of our short form. And then I asked students to make 1 molecule of water, 1 molecule of carbon dioxide, and 1 molecule of oxygen gas. So that's what we did next. And we found oxygen gas was very interesting. We had to have 2 oxygens, and then we had a little bit of a double bond here. We had water molecules. Those are going to be right here, so we drew it in our notebook. And then we had a very curious carbon dioxide where we really had to bend up the bonds there because it wouldn't fit. And all of those bonding arms have to be taken care of or accounted for. You'll see a copy of this page in our notebook. But that's where we started. And then we cleaned up our notebook. Let's get rid of this screen. We'll go back. The last little piece that we did was we went into our Google Classroom account, and I asked students to see if they could get familiar with writing chemical formulas. So I'll show you that real quickly. Open this up into our first period. To do this, we used something called CAMI, and students may be familiar with CAMI. Otherwise, I included a set of instructions on how to use CAMI with the assignment. So we're going to go into classwork, and this week is week 4. You'll see the agenda right there. And so what I was talking about were models of molecules. So when you click that open, you'll see you have this great combination. Again, this is instructions if you're not certain how to do this. And this is another set of guides. But I'm going to go ahead and just show you great combinations as a PDF. And we're going to open this PDF up with CAMI. You can hit the blue button here, or you can do the pull down menu and say annotate with CAMI. We're going to make this as big as we can so we can see it a little bit better. Oh, looks like I've got it already large. And up at the top, you'll see your controls. You'll read this paragraph and you'll see the 2 examples, and then make certain that you start by putting your name on it. So I'm going to ask students not to use red or black because that's going to be hard to see. So I'm going to go with a little bit of purple, and then I'm going to type up here, and I'm going to write my name. And I'm going to include my number, my pocket number in the class. And there it is. My name is up there. And then I'm going to scroll down and I'm going to take a look. Now, if you're doing this on your Chromebook, you have a touch screen. So you can make this super, super big, and then you can write with your finger. But basically, you can also hit text boxes, and you're going to type in here the chemical formula for water using the image. So I'm going to click here. The image has got 2 hydrogens and 1 oxygen. You can do hydrogens first, or you can do oxygen first. Most students probably know it's H2O, but if you don't recognize that, then just go ahead and put whatever you'd like. You're going to put a capital O. There's only 1 of those, so we're not going to put a 1. And then we're going to do a capital H, and there's 2 of those, so I'm going to put a 2 after it. Now I've got to make that 2 small, so I'm going to highlight the 2, and then I'm going to go up to the top row, and there's actually a subscript button right there. I'm going to click that, and it's going to make it small and drop it. And so I've got that first one. Now, we probably should switch that because H2O is water. Again, I think you know that. But if you don't know some of the others, I don't care if you have the letters in the right order, as long as you have the proper number. So, for example, phosphorus pentoxide. So let's go ahead and put our text box in there. I see O's, so I'm going to start with O. And I see P's. Oops, not a colon. How many O's? I got 1, 2, 3, 4, 5. So I'm going to put a 5 in there. And how many P's? 2 of them. So I'm going to put a 2 there. I'm going to grab the 2 and make it a subscript. So back over here, grab the 5, make it a subscript right there, and we're done. So phosphorus, P, pentoxide, pent means 5, so you'll have 5 oxygens. Okay, so keep going on this. That's what I was asking you to do. There is a trick to finishing. Please make certain that you do hit the little save button. There's a little save icon. If you put your cursor over it, it'll say save. I don't know if you're going to recognize this. This thing is something from the 2000s, and it's a hard floppy disk, which is what we used to use to save our materials on our computers before there were big enough drives or a cloud. Anywho, that is all I've got. I'm going to go ahead and get rid of this, come back to our main screen. So your goal is to finish that Models of Molecules in Google Classroom. Thanks, and I'll see you tomorrow.